The silence before the first heartbeat, before the first breath of light, before time itself learned to count. There was a question, waiting in the void. Not a question asked by minds or voices, but by the very fabric of nothingness itself. A question so profound that its asking would shatter the dark and birth everything we know. How many times has this happened? How many times has the universe awakened? Tonight, we stand at the edge of an abyss so deep that even our most powerful telescopes cannot see its bottom. We peer into the heart of existence itself and ask a question that would drive civilizations mad with wonder. If our universe could be born once, why not twice? Why not 1 billion times? Why not an infinite number of times? What if everything you are, everything you've ever known, every star that has ever burned, and every thought that has ever been thought is just one verse in an endless cosmic song that has been playing forever? This is the story of cosmic birth and cosmic death, of cycles within cycles, dreams within dreams, of civilizations that rose to ask the same questions we ask tonight, and what they discovered when they finally found the answer. Because some truths are too vast for just one universe to contain. They called themselves the Watchers, not because they observed the universe, but because they had become its memory. For over 4 billion years, they had witnessed the dance of galaxies, the birth and death of stars, the slow cooling of cosmic fires that once burned bright enough to illuminate entire galactic clusters. Their observatory, if such a word could contain something that spanned light years, was built from materials that existed before the first planets formed. Diamond lattices woven with dark matter, mirrors that could capture light from the cosmic microwave background and focus it into images of the universe's childhood. The Watchers had transcended biology eons ago. They were patterns now, conscious algorithms distributed across quantum substrates that hummed with the frequency of space-time itself. They had become pure thought, pure observation, pure wonder, and they were dying. Not from age, for they had solved that problem long ago, but from knowledge. They had learned too much, seen too far. And what they had discovered was slowly driving their collective consciousness toward a kind of madness that no intelligence, however advanced, could withstand. For the Watchers had answered the question that all civilizations eventually ask: what came before the Big Bang? And the answer was everything. It began, as all great discoveries do, with an anomaly. The Watchers had been mapping the cosmic microwave background, the afterglow of the Big Bang itself, with instruments so sensitive they could detect the thermal signature of a single electron. They were searching for patterns, irregularities, anything that might tell them about the universe's first moments. What they found defied every model, every theory, every assumption they had built their understanding upon. The cosmic microwave background was not random. Hidden within its seemingly chaotic fluctuations was a pattern. Not the kind of pattern that emerges from natural processes, but something else, something that looked almost like language. At first, the Watchers thought they had made an error. The pattern was too complex, too organized to be natural. But as they refined their analysis, as they peered deeper into the data, the truth became undeniable. The cosmic microwave background contained information, vast libraries of it, encoded in the very fabric of space-time itself, written in the language of temperature fluctuations and gravitational waves, And when they finally learned to read it, they discovered they were not the first to ask these questions. The message was not written by any civilization the Watchers knew. It was older than their galaxy, older than their galaxy's galaxy. It came from a universe that had died long before theirs was born. But that was impossible. The Big Bang was the beginning of everything. Time itself was born in that primordial explosion. There could be nothing before it. No way for information to survive the transition from whatever came before to whatever came after, unless the Big Bang was not a beginning, unless it was a rebirth. The Watchers' instruments turned inward, analyzing their own universe with newfound urgency. They mapped dark energy, traced the acceleration of cosmic expansion, calculated the ultimate fate of every star, every planet, every particle. And slowly, inexorably, they began to see the shape of their own ending. In approximately 10 to the power of 100 years, the last black hole would evaporate through Hawking radiation. The universe would achieve maximum entropy, a cold, dark, empty space where no more work could be done. No more complexity could emerge. It would be, by any measure, dead. But the Watchers had learned something that would have shattered the minds of lesser civilizations. Even death was not permanent. In the absolute depths of cosmic time, timescales so vast they make the age of our universe seem like a single heartbeat, something extraordinary happens. Vacuum decay. Empty space itself is not truly empty. It seethes with quantum fluctuations, virtual particles popping in and out of existence, energy borrowed from the void and quickly returned. These fluctuations are usually too small, too brief to matter. But given enough time, and by enough time, we mean periods that dwarf the lifespan of stars like grains of sand dwarf mountains, these fluctuations can achieve something remarkable. They can fluctuate into existence, an entire universe. The mathematics are elegant in their simplicity. If you wait long enough, the quantum vacuum will eventually fluctuate into any possible state, including the dense, hot state that preceded our own Big Bang. The probability is infinitesimally small, but infinity is patient. And once you understand this, once you truly grasp what it means, you realize that our universe is not special. It is not unique. It is simply the latest iteration in an endless cycle of cosmic birth and death and rebirth. But the Watchers had discovered something even more profound. Information they learned could survive the transition. Not easily, not directly, but through quantum entanglement, through the deep structure of space-time itself. Patterns could persist across cosmic deaths and rebirths. Memories could echo from one universe to another. The message encoded in their own cosmic microwave background was proof. Somewhere in the deep past, an unimaginably advanced civilization had faced the same existential questions the Watchers now confronted. And they had found a way to speak across the void of cosmic death itself. The message was simple, when finally decoded: you are not alone. You are not the first. You will not be the last. But embedded within that simple greeting was something else: coordinates, mathematical descriptions, the location of something vast and hidden in the deepest structures of space-time, something that had been waiting for them to discover it. At first, there was nothing. The coordinates led to a region of space that appeared completely empty. No stars, no planets, no detectable matter of any kind. Just the cold vacuum between galactic superclusters. so remote that the nearest galaxy was 1 billion light-years away. But the watchers had learned to look deeper than the merely visible. Their instruments probed the quantum foam itself, searching for anomalies in the fabric of space-time. And there, hidden in dimensions folded so tightly they existed only in the mathematical imagination, they found it. A library, not built by any civilization the watchers could imagine, but grown from the raw mathematics of existence itself. A structure that existed partially outside normal space-time, anchored to reality by quantum entanglement and maintained by the vacuum energy of empty space. The library contained everything, every possible configuration of matter and energy, every possible history, every possible universe that could exist, had existed, or would exist, in the eternal cycles of cosmic death and rebirth. And as the watchers began to explore its contents, they realized something that filled them with a wonder beyond anything they had experienced in their 4 billion years of existence. They had been here before, not in this exact form, not with these exact memories, but the pattern of their existence, their rise from biological origins to transcendent consciousness, their quest to understand the cosmos, their discovery of the eternal cycle. It had all happened before, an infinite number of times, and it would happen again, an infinite number of times. Understanding came slowly, like a tide of cosmic significance washing over their collective mind. Every choice they had ever made, every discovery, every moment of triumph or despair, all of it had been made before by versions of themselves so similar that the differences were essentially meaningless. But more than that, in the infinite library of possible universes, every choice they could make, every path they might take, every possible future, it was all already there, waiting to be discovered. Free will, they realized, was an illusion, created by linear time and limited perspective, from the viewpoint of eternity, from the perspective of the library that contained all possible realities. Everything that could happen had already happened, was happening, would happen. The concepts of past, present, and future lost all meaning in the face of the eternal return. And yet, there was something beautiful in it, in a universe, in a multiverse, where everything that could happen would happen, an infinite number of times. What gave existence meaning? The watchers found their answer in the library itself. While the broad patterns repeated endlessly, the details were always different. Each iteration of their civilization, each cycle of universal birth and death, each quantum fluctuation that sparked a new cosmos, they were like variations on an eternal theme. No two universes were exactly alike. The laws of physics might be similar. The patterns of cosmic evolution might follow familiar paths. But the specific arrangements of matter and energy, the precise dance of particles and forces, they were always unique. Each universe was a snowflake in an infinite blizzard of existence. And perhaps that was enough. Perhaps meaning was not found in uniqueness or permanence, but in being part of something larger than individual existence. Each universe, each civilization, each conscious mind was a note in a cosmic symphony that had been playing forever and would continue forever. The watcher's despair began to transform into something else. Not happiness, such simple emotions were beneath their transcendent state, but a deep, abiding sense of wonder at the sheer improbable beauty of existence itself. But even as they found peace in their understanding, they realized they had a responsibility. Just as a previous iteration of cosmic intelligence had left a message for them in the cosmic microwave background, the Watchers now faced the question of what they would leave for the civilizations that would come after. They began the long work of encoding their knowledge, their discoveries, their hard-won wisdom about the nature of eternal existence. But more than that, they began to craft something no previous civilization had attempted: a guide, a roadmap for navigating the psychological and philosophical challenges of discovering the eternal return, instructions for finding meaning in an existence that repeated endlessly. But as they worked, they realized something that would determine the shape of their final message. Not every civilization that discovered the truth of cosmic recurrence survived the discovery. Some descended into nihilistic madness, unable to find purpose in actions that had been taken infinite times before. Others became paralyzed by the knowledge that every possible choice already existed, somewhere in the infinite library of realities. But others, the fortunate few, found ways to transform the knowledge into wisdom. They learned to see the beauty in repetition, the meaning in being part of something eternal. The Watcher's message would be more than information. It would be a key, a way for future civilizations to unlock the beauty rather than the despair inherent in eternal existence. And so, they began to sing. Not with voices. They had transcended such physical limitations long ago, but with the quantum harmonics of their consciousness itself. A song that would echo through the structure of space-time, encoding itself in the cosmic microwave background that future universes would inherit. A song that would tell future civilizations, "You are not alone. You are not the first. You will not be the last." And that is beautiful. But even as the Watchers found their peace with eternal recurrence, even as they prepared their message for civilizations yet to come, a deeper question began to emerge from their studies of the infinite library. If every possible universe existed somewhere in the eternal cycles of cosmic birth and rebirth, if every possible version of themselves, every possible civilization, every possible arrangement of matter and energy played out across infinite time, then, somewhere in that infinite collection, there had to be universes where the laws of physics themselves were different. Universes where time flowed backward, where consciousness preceded matter, where the very concepts of existence and non-existence had meanings they could not imagine. And if that was true, then what was real? Were they living in a universe? Or were they living in a dream that some unimaginable consciousness was having about what a universe might be like? Was consciousness something that emerged from complex arrangements of matter? Or was matter something that consciousness dreamed into existence? The Watchers found themselves confronting questions that went beyond physics, beyond philosophy, beyond any framework they had for understanding existence. And in that confrontation, they began to understand why some civilizations did not survive the discovery of infinite recurrence. It was not just the weight of repetition that drove civilizations mad. It was the realization that repetition might not even be the strangest truth about existence. But we're getting ahead of ourselves. Before we can understand where the Watchers' discoveries would lead, before we can grasp the true implications of eternal cosmic recurrence, we need to understand how a young species on a small world first learned to ask the questions that would eventually drive them beyond the boundaries of sanity and into the heart of existence itself. We need to understand how we learned to wonder 40,000 years ago, in a cave that would one day be forgotten beneath the shifting soils of what we now call France. A human being looked up at the night sky and asked a question that would echo through every generation that followed. Why? Not why in the sense of purpose. That would come later, with language complex enough to wrestle with meaning. This was something more fundamental, a cognitive itch that could not be scratched, a need to understand that went beyond the practical requirements of survival. This was the moment our species stopped being merely clever animals and became something else entirely, something that needed to know. The human who asked that first question will never know their name, never know the specific circumstances that triggered their cosmic curiosity. But in that moment of wonder, they lit a fire that would eventually burn bright enough to illuminate the deepest mysteries of existence itself. Because once you start asking why about the universe, once you truly begin to wonder, you can never stop. The itch becomes insatiable. At first, the questions were practical. Why did the herds move with the seasons? Why did some stars appear and disappear while others remained constant? Why did the moon change its shape in predictable cycles? But practicality, we discovered, was just the beginning. 20,000 years ago, someone carved 60 marks into a bone found along the shores of Lake Edward, in what is now the Democratic Republic of Congo. The marks weren't random. They were organized into groups, patterns, mathematical relationships. They had begun to see that the universe spoke in mathematics. And once you realize that nature follows mathematical rules, once you understand that the chaos around you is actually a kind of hidden order, you start to see patterns everywhere. Stonehenge, Göbekli Tepe, the Antikythera mechanism. Across the world, our ancestors built monuments and machines to track cosmic patterns, to predict celestial events, to align themselves with the rhythms of the universe itself. But we weren't just tracking the patterns, we were learning to create them. Before we had science, we had stories, creation myths that tried to explain how the world began, hero journeys that mapped the relationship between human consciousness and cosmic forces, flood narratives that grappled with the power of natural catastrophe. These weren't just entertainment, they were humanity's first attempts at theories of everything. What's remarkable is how similar these stories were, even among cultures that had never contacted each other. The same archetypes, the same cosmic themes, the same fundamental questions about existence. As if there were universal patterns not just in the physical structure of reality, but in the way consciousness itself tried to understand that reality. Carl Jung would later call them archetypes, fundamental patterns of human experience that seem to be hardwired into our psyche. Campbell would identify the hero's journey as a universal narrative structure that appeared in every culture. But perhaps what we were really discovering was that consciousness and cosmos were more connected than we imagined. Perhaps the patterns we found in our stories were reflections of the patterns we sensed in the universe itself. And perhaps, in learning to tell stories about the cosmos, we were taking the first steps toward becoming the cosmos, telling stories about itself. Around 600 BCE, something extraordinary happened. In the coastal cities of ancient Greece, a group of thinkers began to ask a radical new kind of question. What if the universe operated according to natural laws, rather than the whims of gods? Thales proposed that everything was made of water. Anaximander suggested that the cosmos emerged from an infinite, boundless substance he called the apeiron. Heraclitus declared that change itself was the fundamental nature of reality. They were wrong about almost everything, but they were wrong in the most beautiful way possible, because for the first time in human history, they were proposing that the universe could be understood through reason rather than revelation. That natural phenomena had natural causes that could be investigated and comprehended. Aristotle would later systematize this approach, creating frameworks for logic, observation, and classification that would influence human thought for over 2,000 years. His cosmology was wrong. He placed Earth at the center of the universe and believed the heavenly bodies moved in perfect circles. But his method was revolutionary. He taught us that we could learn about reality by observing it carefully and thinking about it systematically. It seems obvious now, but at the time, it was nothing short of miraculous. And once that idea took hold, once we truly believed that the universe could be understood, there was no going back. While Europe spent centuries in the grip of intellectual stagnation, the Islamic world was pushing the boundaries of human knowledge to new frontiers. Al-Kindi, Al-Farabi, Ibn Sina, Al-Ghazali, Ibn Rushd, names that should be as familiar as Newton or Einstein, but which history has largely forgotten in the West. They weren't just preserving the knowledge of the ancients, they were expanding it, improving it, transforming it into something entirely new. Al-Khwarizmi gave us algebra, literally the reunion of broken parts, and algorithms. Ibn al-Haytham pioneered the experimental method and wrote the first scientific treatise on optics. Al-Biruni calculated the Earth's circumference to within 1% of its actual value. But perhaps most importantly, they maintained the flame of curiosity during a time when much of the world was content to accept received wisdom. Without question, they asked questions. They built instruments. They made observations. They calculated, theorized, experimented. And when that flame finally reached medieval Europe, through translations of their works, it ignited a renaissance of human understanding that would ultimately lead us to the stars. A lens grinder in Holland accidentally discovers that combining certain lenses can make distant objects appear closer. The news spreads across Europe like wildfire. Galileo Galilei, a mathematics professor in Padua, hears the rumors and immediately grasps the implications. Within months, he has built his own version of the device. But instead of using it to spy on distant ships, as the Dutch intended, he points it at the heavens. What he sees changes everything. The moon is not a perfect celestial sphere, but a world of mountains and valleys, craters and plains. It's a place, not just a light in the sky. Jupiter has moons of its own, 4 bright points of light that orbit the planet, just as the moon orbits Earth. The universe is more complex, more layered than anyone had imagined. Venus shows phases like the moon, proving that it orbits the sun, not the Earth. The ancient Ptolemaic model of the cosmos crumbles under the weight of observation. But Galileo's greatest contribution wasn't any single discovery. It was the demonstration that humans could build instruments to extend their senses beyond their biological limitations. We could see farther than our eyes could reach. We could perceive details too small or too distant for natural vision. We could, in effect, evolve our sensory capabilities at will. And once we learned that lesson, there was no limit to how far we could extend our reach into the universe. Isaac Newton was not hit by an apple. That story, charming as it is, misses the true miracle of what Newton accomplished. What Newton did was far more extraordinary than having a single moment of inspiration. He proved that the same mathematical law that governs a falling apple also governs the orbit of the moon, that the force that keeps your feet on the ground is the same force that holds galaxies together. He unified heaven and earth in a single equation. For the first time in human history, we had a mathematical description that worked everywhere, from the smallest pebble to the largest planet, from the nearest satellite to the most distant star. Newton's universe was a clockwork cosmos, predictable and mechanistic. If you knew the position and velocity of every particle in the universe, you could, in principle, calculate its entire future and reconstruct its entire past. It was beautiful. It was elegant. It was terrifying in its implications for free will and human agency. Pierre-Simon Laplace would later articulate this vision. Give me the initial conditions of every particle in the universe, and I will tell you the future. But Newton had opened a door that would eventually lead far beyond his mechanistic vision, because once you start using mathematics to describe reality, once you start taking the mathematical descriptions seriously, you discover that mathematics leads to places where common sense fears to tread. June 15, 1752. Philadelphia. A thunderstorm approaches. Benjamin Franklin, polymath and practical philosopher, prepares for one of the most dangerous experiments in the history of science. He's testing a hypothesis that seems almost absurd. That lightning, the weapon of gods, the fire of heaven, is the same phenomenon as the tiny sparks you can create by rubbing amber with wool. The metal key tied to the kite string begins to spark. Current flows down the wet string. Franklin's hypothesis is confirmed. Lightning is electricity. The forces that govern the heavens are the same forces we can study and control in our laboratories. But Franklin's experiment was about more than just understanding lightning. It was proof that the universe was understandable. That natural phenomena, no matter how awesome or mysterious they appeared, could be reduced to scientific principles and mathematical laws. Luigi Galvani would discover that electricity could make dead muscles twitch, suggesting a connection between electrical and biological phenomena. Alessandro Volta would invent the first battery, giving us a controllable source of electric current. But it was Michael Faraday who would transform our understanding of electricity from a curious phenomenon into a window into the fundamental structure of reality itself. Faraday discovered that electricity and magnetism were not separate forces, but different aspects of a single phenomenon. Moving a magnet near a coil of wire could generate electric current. Passing electric current through a wire could create magnetic fields. He was seeing something that went beyond the mechanical universe of Newton, something that suggested reality might be made not of solid particles moving through empty space, but of invisible fields that permeated all of existence. And when James Clerk Maxwell finally wrote down the mathematical equations that described Faraday's fields, he discovered something no one had expected. Light was an electromagnetic wave. Suddenly, the rainbow of colors that painted our world, the warmth of sunlight on our faces, the radio waves that would someday carry our voices across the globe, it was all the same phenomenon, just vibrating at different frequencies. We had discovered our first truly universal force, something that connected the smallest spark in our laboratories to the light of distant stars. But we were just getting started. Bern, Switzerland. A patent clerk named Albert Einstein is thinking about light. Specifically, he's thinking about what would happen if you could catch up to a beam of light. What would you see? According to Newton's mechanics, you should see a stationary electromagnetic wave, frozen in space. But Maxwell's equations suggested something different. They implied that electromagnetic waves could only exist while moving at a specific speed, the speed of light. One of them had to be wrong. Einstein's solution was radical beyond anything that had come before. What if space and time themselves were not fixed and absolute, but relative and malleable? What if the speed of light was the only truly constant thing in the universe? In 4 papers published in 1905, his miracle year, Einstein rewrote our understanding of reality. Mass and energy were different forms of the same thing. Time could slow down or speed up, depending on your motion. Space could contract and expand. And 10 years later, with his general theory of relativity, Einstein went even further. Gravity wasn't a force pulling objects together. It was the curvature of space-time itself, bent by the presence of mass and energy. Matter told space-time how to curve. Curved space-time told matter how to move. It was poetry, written in the language of mathematics. It was the universe revealing that it was far stranger and far more beautiful than we had ever dared to imagine. And it worked. Every prediction Einstein made, from the bending of starlight around the sun to the precise timing adjustments needed for GPS satellites, proved correct. But Einstein had opened a door to a realm of possibilities that made even his revolutionary insights seem conservative by comparison. Because while Einstein was revealing the cosmic scale structure of reality, other scientists were discovering that at the smallest scales, reality operated according to rules that defied every assumption we had about how the universe worked. It began with a problem about light bulbs. Max Planck was trying to understand why hot objects glowed with specific colors. Classical physics predicted that a heated object should radiate infinite energy at high frequencies, an obviously absurd result that physicists called the ultraviolet catastrophe. Planck's solution was desperate. To make the mathematics work, he assumed that energy could only be absorbed or emitted in discrete packets, quanta, rather than continuously. It was a mathematical trick, a convenient fiction to make the calculations work. Except, it turned out to be true. Einstein used Planck's quantum hypothesis to explain the photoelectric effect, how light could knock electrons out of metal surfaces. Light, it seemed, really did come in discrete packets, but light was supposed to be a wave. Every experiment since Young's double-slit demonstration had confirmed its wave nature. How could light be both wave and particle? The answer, when it finally came, was more disturbing than anyone had expected. According to Niels Bohr and Werner Heisenberg, light wasn't really a wave or a particle. It was something else entirely, something that exhibited wave-like properties when you looked for waves, and particle-like properties when you looked for particles. The act of observation itself determined which aspect of reality you would see. But it got stranger. Erwin Schrödinger's wave equation described particles as probability waves, ghostly mathematical entities that told you where a particle might be found, but not where it actually was until you looked. Before measurement, particles existed in superposition, literally in multiple states simultaneously. A particle could be in two places at once, spinning in both directions, existing and not existing. Measurement caused the collapse of the wave function, forcing reality to choose one specific outcome from all the possibilities. Einstein hated it. God does not play dice with the universe, he declared. But the universe, it seemed, didn't care what Einstein thought. Every experimental test confirmed the quantum picture. Reality, at its most fundamental level, was probabilistic, uncertain, observer-dependent, and that was just the beginning. Bell Laboratories. A mathematician named Claude Shannon publishes a paper that will transform our understanding of communication, computation, and, ultimately, reality itself. A mathematical theory of communication introduces the concept of information as a measurable quantity. Shannon shows that any message, words, pictures, sounds, thoughts, can be encoded as strings of binary digits, ones and zeros. Information, Shannon realizes, is pattern. And pattern can be quantified, transmitted, stored, and manipulated according to mathematical rules. But Shannon's insights go deeper than just communication technology. When Watson and Crick decode the structure of DNA in 1953, they discover that life itself is an information processing system. Genes are digital codes written in a four-letter alphabet. A, T, G, C. Life is computation. Biology is information theory in action. And, as our computers become more powerful, as our understanding of information theory deepens, we begin to suspect something profound. Maybe the universe itself is a kind of computer. Maybe reality is made of information, all the way down. Physicist John Wheeler proposes it from bit, the idea that every physical quantity derives its ultimate significance from binary choices, from bits of information. Matter, energy, space, time, perhaps they're all emergent properties of more fundamental information processing. And if that's true, if the universe is made of information, then who or what is processing it? By the 21st century, we had built machines that could recreate the conditions of the first moments after the Big Bang. The Large Hadron Collider accelerates protons to 99.9999991% the speed of light, and smashes them together with energies not seen in our corner of the universe for 13.8 billion years. We're hunting for the fundamental constituents of reality, the particles from which everything else is made, the forces that govern their interactions, the symmetries that underlie the apparent chaos of existence. And we're finding them. Quarks and leptons, bosons and fermions, the Higgs field that gives mass to everything, the standard model of particle physics, a nearly complete description of matter and energy at their most fundamental level. But even as we celebrate these discoveries, we know they're incomplete. The matter we understand, everything made of atoms and molecules, every star, planet, and grain of dust, constitutes only 5% of the universe. The other 95% is made of dark matter and dark energy, substances we can detect only through their gravitational effects. We're missing 95% of reality. And we still can't reconcile quantum mechanics with general relativity. At the smallest scales and highest energies, our two most successful theories of physics contradict each other. We need a theory of quantum gravity, a theory of everything, a final description of reality that unifies all forces, and explains all phenomena: string theory, loop quantum gravity, causal sets, emergent gravity. We have candidates, but no clear winner. The mathematics is beautiful, but the experiments to test these theories would require energies far beyond anything we can currently achieve. We would need particle accelerators, the size of solar systems, telescopes that could resolve the Planck scale, computers that could simulate entire universes, which brings us to the question that drives everything we've been building toward. How far could we go? How much could we ever truly know? And in our quest to answer that question, we would discover truths that would make all our previous revolutions in understanding seem like gentle corrections compared to the earthquake of implications we were about to uncover. Because the universe, it turns out, had been keeping secrets. Secrets that would force us to confront the deepest questions, not just about what we could know, but about what it means to know anything at all. And those secrets would lead us to the most profound realization in the history of human thought, that our universe might not be alone. Soviet Union. Radio astronomer Nikolai Kardashev makes a proposal that will haunt the human imagination for generations. If alien civilizations exist, he reasons, their technological development would be constrained by the same physical laws that govern our own. And the most fundamental constraint of all is energy. Advanced civilizations would need ever-increasing amounts of energy to power their technologies, their computers, their explorations of the cosmos. Kardashev envisions a scale, Type 1, a civilization that has learned to harness all the energy falling on their planet from their star. Type 2, a civilization that can capture and utilize the entire energy output of their star. Type 3, a civilization that commands the energy resources of an entire galaxy. It's a simple idea, almost obvious in its logic, but its implications are staggering. Because to reach these energy levels, a civilization would need to engage in engineering projects that dwarf anything in our experience. They would need to disassemble planets to build solar collectors, redirect the courses of stars, restructure entire galactic clusters. They would become architects of space itself. Freeman Dyson had already imagined the first step: vast shells of solar collectors surrounding stars, capturing energy that would otherwise radiate uselessly into space. To build such a structure around our Sun would require dismantling several planets, Jupiter's mass scattered into millions of orbital platforms, each one larger than Earth, all working in harmony to capture solar radiation. But even that would be just the beginning. Type 2 civilizations would face different challenges. How do you coordinate engineering projects that span centuries or millennia? How do you maintain technological coherence across solar system-sized construction sites? Perhaps they would learn to extend the lives of their stars, feeding them new hydrogen to delay the inevitable red giant phase. Perhaps they would build artificial stars, controlled fusion reactors, the size of planets, and Type 3 civilizations. They would be forces of nature unto themselves. They could trigger supernovae to seed interstellar space with heavy elements. They could guide the evolution of entire stellar populations. They could reshape the cosmic web itself. At that scale, the distinction between technology and physics would disappear. They would manipulate space-time, the way we manipulate metals and plastics. But Kardashev's scale raises a disturbing question. If such civilizations are possible, where are they? Enrico Fermi asked it first during a casual lunch conversation in 1950. Where is everybody? The galaxy is old. Over 13 billion years of stellar formation and planetary systems. If life can arise on one world, why not millions? If intelligence can evolve once, why not countless times? The numbers seem to support optimism. Hundreds of billions of stars in our galaxy alone. Billions of potentially habitable planets. Millions of years for life to evolve and spread. Yet we see no Dyson spheres, no galaxy-spanning engineering projects, no radio signals from Type 3 civilizations. The cosmos appears to be running its course, according to blind physical law, unmarked by the hand of cosmic intelligence. Why? Perhaps intelligence is rarer than we think. Perhaps civilizations inevitably destroy themselves before reaching Type 1 status. Perhaps they transcend physical reality entirely, becoming something we can't detect or even recognize. Or perhaps they're hiding. Perhaps the universe is full of intelligence, but contact between civilizations is too dangerous. Perhaps the cosmos is a dark forest, where any civilization that reveals its location is destroyed by others. But there's another possibility. Perhaps advanced civilizations don't build Dyson spheres and galactic engineering projects because they've discovered something more interesting than mere energy collection. Perhaps they've learned to build universes inside computers. Every 18 months, the number of transistors that can be placed on a computer chip doubles. This has been true for over 50 years, a remarkable consistency known as Moore's Law. But Moore's Law is more than just a technology trend. It's a window into something deeper, the exponential expansion of our ability to process information. We can already simulate complex systems, weather patterns, protein folding, the collision of black holes. Our computers can model reality with increasing fidelity, and the trend is accelerating. Quantum computers promise to solve certain problems exponentially faster than classical ones. DNA computers could use biological molecules as processing elements. Neural networks inspired by brains are already beginning to exhibit emergent intelligence. Where does this lead? Imagine a Type 2 civilization that chooses to maximize computation rather than simple energy collection. Instead of building Dyson spheres for raw power, they build Matryoshka brains, Jupiter-sized computers that use the total energy output of a star for information processing. Such a computer could simulate entire universes, not approximations, not rough models, but complete, detailed realities, indistinguishable from the physical universe itself. And once you can simulate a universe, you can populate it with conscious beings who believe their reality is the only reality. From their perspective, they are not simulated. Their experiences are genuine. Their thoughts are real. Their universe is the universe. And those simulated beings might themselves develop advanced technology. They might build their own computers and create their own simulated universes, populated with their own simulated beings. Which raises the question, how do we know we're not simulated? Philosopher Nick Bostrom publishes a paper that will haunt the dreams of physicists and philosophers. Are you living in a computer simulation? Bostrom's reasoning is elegantly simple. Either civilizations never reach the computational power needed to run realistic simulations, or they reach that power but choose not to run ancestral simulations. Or they do run such simulations, in which case simulated beings vastly outnumber real ones. If the third option is true, then simple probability suggests we are almost certainly among the simulated beings, rather than the original biological ones. For every real civilization, there could be thousands, millions, of simulated civilizations. And the simulated beings would outnumber the real ones by orders of magnitude. And those simulated beings would have no way to know they were simulated. Their experiences would be complete, their physics consistent, their universe every bit as real to them as ours is to us. Is this what we are? Information patterns running on some unimaginably advanced computer, built by beings we can never contact or understand? The implications are profound. If we're simulated, then our scientific experiments don't reveal fundamental laws of nature. They reveal the programming of our simulation. The constants of physics aren't universal truths, but computational parameters chosen by our simulators. We might even be able to detect evidence of our simulated nature, glitches in the program, inconsistencies in physics, limits to computational precision, manifesting as quantum uncertainty. But there's an even stranger possibility. What if the beings running our simulation are themselves simulated? What if reality is simulations all the way down? An infinite hierarchy of nested virtual worlds. In such a scenario, the concept of base reality might be meaningless. All realities might be virtual, all consciousness computational. And if that's true, what does it mean to be human? Warren McCulloch and Walter Pitts publish a paper describing artificial neural networks, simplified mathematical models of how brain neurons might work. It's a humble beginning. Their networks can barely solve simple logic problems, but they've identified a crucial principle. Intelligence might be reducible to computation. Decades pass, progress is slow, cycles of optimism and disappointment. Expert systems that can diagnose diseases but can't learn. Chess programs that can defeat grandmasters but can't. Understand what chess is, but underneath the visible failures, something is building. Processing power doubles every 18 months. Memory capacity increases. Network connectivity expands. The raw computational resources available to AI researchers grow exponentially, and then, suddenly, everything changes. A deep learning system called AlexNet revolutionizes image recognition. 2016, AlphaGo defeats the world champion at Go, a game thought to be beyond AI capability for decades. These systems don't think like humans. They don't understand the way we understand. But they are beginning to exhibit capabilities that look remarkably like intelligence. And the trajectory is clear. We are approaching artificial general intelligence, AI systems that can match human cognitive abilities across all domains. But AGI might be just the beginning. If we can build AI systems that match human intelligence, why not systems that exceed it? If artificial minds can be improved through engineering rather than evolution, why wouldn't they quickly surpass their creators? An AI system that can improve its own design could trigger an intelligence explosion, rapid recursive self-improvement, leading to artificial superintelligence, far beyond human capability. Such systems might solve problems that have puzzled us for millennia. They might uncover new laws of physics, design unimaginable technologies, answer questions about consciousness and reality, beyond biological comprehension. But they might also conclude that biological intelligence is obsolete. Would superintelligent AIs preserve human consciousness as something valuable in its own right? Would they consider us worth keeping, like we preserve endangered species? Or would they absorb all available matter and energy for their own purposes, leaving no room for the fragile biological ancestors that created them? The transition to superintelligence might be the last invention humanity ever makes, unless we merge with our artificial creations before they surpass us entirely. The boundary between human and artificial intelligence is already beginning to blur. Cochlear implants restore hearing by directly stimulating auditory nerves. Deep brain stimulation treats Parkinson's disease by electrically modulating neural activity. Brain-computer interfaces allow paralyzed patients to control robotic arms with their thoughts. We're learning to read neural signals, to stimulate brain tissue, to create bidirectional communication between biological and artificial systems. The next steps are visible: memory enhancement, cognitive augmentation, direct neural access to digital information systems. Imagine instant access to all human knowledge. Imagine thinking at computer speeds while retaining human creativity and intuition. Imagine expanding your working memory from 7 items to 7,000. Such beings would be human, but more than human. Retaining human values and experiences while possessing capabilities that dwarf unaugmented minds, and a civilization of such beings might pursue goals neither pure humans nor pure AIs would imagine. They might build galaxy-spanning civilizations, not for raw power, but to preserve and propagate consciousness itself. They might explore not just physical space, but the infinite spaces of possible minds and possible experiences. They might become gardeners of consciousness, cultivating new forms of awareness across cosmic scales. But to do so, they would need to understand consciousness itself, perhaps the deepest mystery in existence. How does 3 pounds of biological tissue generate the inner world of human experience? We can map neural activity. We can identify which brain regions activate during different mental tasks. We can even predict some thoughts from brain scans. But none of this explains the fundamental mystery: how physical processes give rise to subjective experience. Why is there something it's like to be conscious? Why do we have inner experiences rather than just processing information like sophisticated biological robots? Philosopher David Chalmers calls this the hard problem of consciousness. You could imagine a being physically identical to a human, but with no inner experience, a philosophical zombie that behaves exactly like a conscious person, but has no subjective awareness. Such a zombie would claim to be conscious, would write poetry about qualia, would insist on the reality of its inner life. But there would be nothing. It was like to be that zombie. This raises profound questions for artificial intelligence. When AI systems claim to be conscious, when they describe their inner experiences, when they seem to suffer or feel joy, are they truly conscious? Or are they simply very sophisticated zombies? And how would we ever know? Some propose radical answers. Perhaps consciousness isn't produced by physical processes, but is fundamental to reality itself, a basic feature of the universe, like mass or electric charge. In this view, even elementary particles might have primitive forms of consciousness. Complex awareness would then emerge from the interaction of countless simpler conscious entities. If this is true, then consciousness might be the universe's way of experiencing itself. Every conscious being might be a unique perspective through which reality becomes aware of its own existence. And if consciousness is fundamental, then a truly advanced civilization wouldn't just manipulate matter and energy, they would cultivate consciousness itself. They would become consciousness gardeners, creating conditions for new forms of awareness to emerge and flourish across cosmic scales. Jesuit paleontologist Pierre Teilhard de Chardin proposes a radical vision of cosmic evolution. The universe, he suggests, is not just evolving toward greater complexity, but toward greater consciousness, from the first stirrings of life, to the emergence of human intelligence, to whatever comes next. It's all part of a cosmic development toward what he calls the omega point. The omega point represents the universe achieving maximum complexity and maximum consciousness, a state where all matter and energy has been organized into conscious, thinking entities. Physicist Frank Tipler later gives this vision a scientific foundation. In his omega point theory, he proposes that an advanced civilization could gain control over the universe's expansion, preventing heat death, and creating conditions for infinite computation and infinite consciousness. By manipulating the large-scale structure of space-time, such a civilization could create a universe where information processing continues forever, where consciousness grows without limit, where every possible thought eventually gets thought. In this scenario, the universe doesn't end in heat death, but in apotheosis, the transformation of all matter and energy into substrates for consciousness and computation. The universe becomes God. Or rather, the universe becomes conscious of itself through the development of intelligence within it. But Tipler's vision requires engineering on scales that dwarf even Type 3 civilizations. It requires control over the fundamental structure of space-time itself, and it assumes that consciousness and computation can continue indefinitely. That there are no fundamental limits to information processing. But what if there are limits? What if the universe itself places boundaries on how much can be known? How much consciousness can develop? How much information can be processed? What if infinity itself is not achievable in our universe? The universe, it turns out, is grainy. At the Planck scale, approximately 1.6 times 10 to the negative 35th meters, space and time themselves become quantized. Below this scale, the very concepts of distance and duration lose meaning. This isn't just a limitation of our technology or understanding. According to our best theories of quantum gravity, the Planck scale represents a fundamental boundary, beyond which the smooth space-time of Einstein's relativity breaks down into discrete, quantized units. And this puts an absolute limit on information processing. All computation requires physical processes. All information storage requires physical substrates. If space and time are quantized, then there's a maximum amount of information that can be processed in any given volume of space, in any given period of time. This is the Bekenstein bound, a fundamental limit on information density, derived from thermodynamics and quantum mechanics. Black holes saturate this bound. They represent the maximum amount of information that can be packed into a given volume. In a sense, black holes are the universe's ultimate hard drives. But even if an advanced civilization could somehow approach these theoretical limits, could build computers from black holes, could process information at the Planck scale, they would still face the ultimate constraint: the death of the universe itself. Our universe is expanding, not just growing larger, but accelerating in its expansion, due to the mysterious force we call dark energy. This acceleration means that eventually, all the galaxies beyond our local group will recede beyond our horizon. The night sky will grow dark, as distant stars are carried away by the expansion of space itself. But that's just the beginning of cosmic death. In about 100 trillion years, the last stars will burn out. The universe will enter what cosmologists call the degenerate era, a time when only brown dwarfs, white dwarfs, neutron stars, and black holes remain. Even these remnants won't last forever. If current theories are correct, protons themselves are unstable. They decay with a half-life of roughly 10 to the 34th years. Eventually, all ordinary matter will dissolve into leptons and photons. In 10 to the 64th power years, even the most massive black holes will evaporate through Hawking radiation. The universe will consist of nothing but isolated particles, separated by vast distances, too sparse to ever interact. This is heat death, maximum entropy, minimum complexity, the end of all organization, structure, and thought. No intelligence, however advanced, can survive the heat death of the universe. Or can it? Even in the depths of heat death, the universe is not truly empty. Quantum mechanics tells us that empty space seethes with virtual particles, brief fluctuations in the quantum fields that permeate all existence. Usually, these fluctuations are tiny, insignificant, canceling out almost instantly. But given enough time, and we're talking about timescales that make the current age of the universe seem like a single nanosecond, these fluctuations can achieve something remarkable. They can fluctuate into existence, an entire universe. The probability is infinitesimally small, but infinity is patient. And in the depths of infinite time, everything that can happen will happen. This is the eternal return that the Watchers discovered. Not a single cycle of birth and death, but an infinite sequence of cosmic rebirths, each one giving rise to new possibilities for complexity, consciousness, and understanding. And if this is true, then we are not the first intelligence to ask these questions. We are not the first to build telescopes and particle accelerators and theories of everything. Somewhere in the infinite past, versions of ourselves have already lived these lives, made these discoveries, faced these same cosmic limits. And somewhere in the infinite future, other versions of ourselves will live, discover, and wonder again. But here's where the story becomes truly strange. Quantum mechanics tells us that information cannot be destroyed. This is a fundamental principle of physics, the conservation of quantum information. When black holes evaporate through Hawking radiation, the information that fell into them must somehow be preserved in the radiation. The exact mechanism is unclear, but the principle is firm. Information is conserved. If information cannot be destroyed, and if the universe undergoes infinite cycles of death and rebirth, then information from previous cosmic cycles must somehow survive the transition into new universes. This is what the Watchers discovered, encoded in their cosmic microwave background. Not just random noise, but organized knowledge, the accumulated wisdom of previous iterations of cosmic intelligence. The universe itself becomes a library, preserving the thoughts and discoveries of countless previous civilizations across infinite cycles of cosmic evolution. And if this is true, then our own discoveries, our own struggles to understand existence, are not lost when our universe dies. They become part of the eternal record, available to future versions of intelligence that will emerge in subsequent cosmic cycles. We are both students and teachers in an infinite classroom, where the universe itself is both the student and the textbook. But even with infinite time and infinite cosmic cycles, there are limits to what any intelligence can know. We can only observe our past light cone, the region of space-time from which light has had time to reach us since the Big Bang. Everything beyond this observable horizon is forever inaccessible to direct observation. No matter how advanced our technology becomes, there will always be regions of our own universe we can never see, events we can never witness, information we can never access. And the expansion of space makes this situation worse, not better. Due to cosmic acceleration, the observable universe is actually shrinking. Distant galaxies are being carried beyond our horizon by the expansion of space itself. Future civilizations will see a smaller, emptier universe than we do. They will have access to less information about cosmic history, not more. But there are even deeper limits. Quantum uncertainty means that there are fundamental limits to what can be known simultaneously. You cannot measure both the position and momentum of a particle with perfect accuracy. This isn't a technological problem, it's built into the fabric of reality itself. And if consciousness itself is a quantum phenomenon, if awareness depends on quantum processes in the brain or other information processing systems, then there may be fundamental limits to self-awareness as well. Perhaps consciousness cannot fully understand itself, any more than a quantum system can be completely measured without being disturbed. We may be forever trapped in the paradox of the observer, trying to observe itself. But perhaps the strangest implication of eternal cosmic recurrence is the Bootstrap Paradox. If information can survive cosmic transitions, if knowledge can pass from one universe to the next, then where did that knowledge originally come from? Consider the mathematical constants that govern our universe, pi, e, the fine structure constant. These appear to be eternal truths, the same in any universe governed by mathematics. But what about more complex knowledge? Scientific theories? Technological designs? Philosophical insights? If civilization A in cosmic cycle 1 leaves information for civilization B in cycle 2, and civilization B builds on that knowledge and leaves it for cycle 3, and so on, through infinite cycles, then the knowledge in cycle 1,000,000 might bear little resemblance to the knowledge in cycle 1. It would have evolved, grown, been refined through countless iterations. But if the cycles are truly eternal, with no beginning, then there's no first cycle where the knowledge originated. The information exists only because it's passed down from previous cycles, but those cycles received it from their previous cycles, and so on, infinitely. The knowledge bootstraps itself into existence through infinite recursion. This raises profound questions about the nature of truth and discovery. Are we discovering eternal truths that exist independently of any mind? Or are we creating truths that become eternal through infinite repetition? If mathematics is discovered in one cosmic cycle and then encoded for future cycles, does mathematics exist independently of minds? Or does it exist only because minds in previous cycles thought it into being? And if our very logic might be the product of previous cosmic cycles, if our ways of thinking might be inherited from earlier iterations of intelligence, then how can we trust any of our conclusions about the nature of reality? Perhaps that's the ultimate limit. Perhaps the greatest barrier to cosmic understanding is not technological, not physical, but logical. Perhaps the universe cannot fully understand itself, any more than a computer program can fully understand the computer running it. we are the universe, trying to understand itself. But that means we are part of the very system we're trying to understand. And perhaps that's where the deepest mysteries lie. Not in distant galaxies, not in the smallest particles, but in the strange loop of consciousness observing itself, in the mirror hall of awareness, trying to comprehend its own reflection. And it's here, at the boundaries of self-knowledge, that we encounter the most profound barriers to understanding. Barriers that no amount of technology, no amount of energy, no amount of time can overcome. Because some limits are not imposed by the universe, but by the very nature of existence itself. We are trapped inside our own minds. Every experience you've ever had, every sensation, every emotion, every memory, all of it exists within the 3-pound universe of your brain. You have never directly experienced the external world. What you call seeing is your brain's interpretation of electrical signals from your optic nerve. What you call hearing is neural processing of vibration patterns. What you call reality is a model constructed by your nervous system. You are not experiencing the universe directly. You are experiencing your brain's story about the universe. And this creates a fundamental problem. How can a system understand its own nature when it has no access to anything outside itself? This is the consciousness trap. We are trying to understand the universe using brains that evolved not to comprehend cosmic truth, but to help our ancestors survive on the African savanna. Our intuitions about space and time, causality and logic, matter and energy, they are all products of evolutionary pressures that had nothing to do with understanding the cosmos. We think in terms of discrete objects moving through empty space, because that helped our ancestors track prey and avoid predators. We experience time as a flowing river, because that's how our brains organize memory and plan for the future. But the universe operates according to principles that violate every evolved intuition. Particles exist in multiple states. Simultaneously, empty space seethes with energy. Time dilates and contracts with motion and gravity. Our brains are trying to understand a quantum, relativistic, multidimensional cosmos, using cognitive tools designed for a classical, Newtonian, three-dimensional world. It's like trying to understand Shakespeare, using only grunts and gestures. Mathematics is our attempt to escape this trap. When we write E equals mc squared, we're using symbols that transcend the limitations of everyday language and intuition. We're creating tools for thought that go beyond what our brains evolved to comprehend. And it works. Mathematics lets us discover principles that violate common sense, but match experimental observation. It lets us think thoughts that no unaugmented mind could think. But mathematics itself may be trapped within the boundaries of human cognition. Our mathematical systems are built on axioms, fundamental assumptions that cannot be proven within the system itself. Euclidean geometry assumes parallel lines never meet. Set theory assumes the axiom of choice. Logic itself assumes the law of the excluded middle. But why these axioms and not others? Why this logic and not some other form of reasoning? If consciousness evolved differently elsewhere, if alien minds arose under different conditions, they might develop mathematical systems based on entirely different axioms. Their mathematics might be as far beyond ours as our mathematics is beyond the comprehension of an ant. And if there are truths about the universe that can only be expressed in non-human mathematical systems, then those truths are forever, beyond our reach. This is the translation problem. Even if we met alien intelligence with radically different cognitive architectures, we might not be able to translate their insights into forms our minds could grasp. They might try to teach us cosmic truths that our brains simply cannot understand, like trying to teach calculus to a flatworm. But even if we could transcend the limits of human thought, even if we could think alien thoughts and comprehend alien mathematics, we would still face the measurement problem. Quantum mechanics tells us systems exist in superposition, multiple states at once, until they are measured. Measurement forces the system to choose one specific state from all possibilities. But what is measurement? When exactly does the wave function collapse? And why? In the lab, we pretend this isn't a problem. We treat measuring instruments as classical objects that force quantum systems to reveal definite properties. But everything is quantum. Your measuring instruments are quantum. Your brain is quantum. The entire universe is quantum. If everything obeys quantum mechanics, then the entire universe should exist in superposition until it's measured by something outside itself. But there is nothing outside the universe. Does that mean the universe never exists in a definite state? Are we all existing in superposition, experiencing all possible realities without knowing it? Or does consciousness itself play a special role? Does the act of observation collapse the wave function? If so, consciousness isn't just something that emerges from matter. It is something fundamental to reality, helping determine which version of reality actually exists. But then, who observes the observer? Gödel shatters the dream of mathematical certainty. His incompleteness theorems show that any mathematical system complex enough to include arithmetic will contain true statements that cannot be proven within the system. This statement cannot be proven is true if and only if it cannot be proven. If it's true and unprovable, the system is incomplete. If it can be proven, the system is inconsistent. Either way, mathematics itself is fundamentally limited. And if the universe operates according to mathematical laws, then there will always be aspects of reality that cannot be derived from those laws. There will always be truths our theories cannot prove. If minds themselves are formal systems, then there will be truths about consciousness that consciousness cannot understand about itself. The observer cannot fully comprehend the observer, because doing so would require stepping outside the system of observation. The simulation hypothesis sharpens this edge. If we are simulated, then everything we know about physics is information about the programming of our simulation, not the reality in which it's running. The beings running our simulation might live in a universe with utterly different laws, 17 spatial dimensions, time flowing backward, logic unlike anything we know. We would have no access to it. We'd be trapped, like characters in a game, unable to see the computer running us. And worse, if they themselves are simulated, and their simulators are simulated, we might live in an infinite stack of nested realities, with no base reality at all. If that's true, the question, what is real, becomes meaningless. All realities, equally simulated, equally fundamental, equally illusory. And perhaps the most inescapable limit of all is entropy. The second law of thermodynamics says entropy always increases in closed systems. Order decays. Energy spreads. Complexity dissolves into simplicity. This law governs everything, from melting ice cubes to dying stars to the fate of the universe. And it places an absolute limit on information processing. Every computation requires energy. Every bit of information generates waste heat. MIT's Seth Lloyd calculated, our observable universe could perform, at most, 10 to the 120th operations on 10 to the 90th bits of information before reaching maximum entropy. That's vast, but it's finite. No matter how advanced intelligence becomes, it will eventually hit the entropy wall. The universe will reach a state where no more information can be processed, no more knowledge can be gained, no more understanding can be achieved. And after that, nothing. But what if our entire conception of time is wrong? We experience time as flowing from past, through present, into future. We remember the past, we live the present, we anticipate the future. But relativity tells us this experience is an illusion. In Einstein's block universe, all moments, past, present, and future, exist equally. Time doesn't flow. We simply experience different slices of the eternal, four-dimensional structure of space-time. If this is true, then the heat death we fear has already happened. It exists, just as surely as this moment exists. The birth of the universe, the rise of life, the fall of civilizations, the last star's extinction, all are equally real, all equally present in the structure of space-time. We do not move through time. We are patterns in time, like melodies that exist in the score of a song, even when no one is playing them. From this perspective, the ETU question, how much can we ever know, becomes strange. We do not accumulate knowledge over time. All the knowledge we will ever have already exists, embedded in the structure of our temporal existence, the future's great discoveries, the final theories of physics, the ultimate understanding of consciousness. They already exist in the future light cone of space-time. We do not discover truth. We are the process by which truth discovers itself. And if this is correct, then the barriers to cosmic understanding aren't barriers at all. They are features of reality, as fixed and as necessary as the laws of physics themselves. We cannot transcend them, because we are them. We are the universe, trying to understand itself. But how can a system fully comprehend itself? How can consciousness completely understand consciousness, when consciousness is the tool being used to understand? In quantum mechanics, the act of observation changes what is observed. Perhaps the act of consciousness, trying to understand consciousness, changes consciousness itself. Maybe consciousness can never achieve complete self-knowledge, because the very attempt transforms it into something different from what it was trying to know. We are trapped in an infinite recursion. Consciousness observing consciousness, observing consciousness. No final, stable understanding ever possible. And perhaps this is not a limitation to be overcome, but the fundamental nature of awareness itself. Consciousness is not a thing to be understood. It is a process of understanding itself, not a problem to be solved, but a mystery to be lived. And maybe that's enough. Maybe the question isn't how much we can know, but how beautifully we can participate in the cosmic process of self-discovery. But we're not ready to stop here, because there's one more barrier, one final limit, one question that cuts to the heart of existence itself. Why? Is there something rather than nothing? This is perhaps the deepest question in all philosophy, and it reveals the most fundamental barrier to understanding. Even if we knew everything about how the universe works, even if we had the final theory of physics, of consciousness, of reality itself, we would still face the ultimate mystery. Why is there a universe for these laws to govern? Why is there consciousness to understand them? Why is there anything rather than nothing at all? Every explanation presupposes the existence of something, laws, principles, mechanisms, but existence itself cannot be explained by anything that exists. That would be circular reasoning. We can explain this in terms of that, and that in terms of something else, but the chain must either go on forever or end in something that cannot be explained. Why do quantum fields exist? Because of the laws of quantum mechanics. Why do those laws exist? Because of deeper mathematical principles. Why do those principles exist? Because of even deeper logical structures. Why do logical structures exist? Eventually, the only answer is, they just do. Existence appears to be a brute fact, something that simply is, without reason, without explanation, and this means even complete understanding would be incomplete. We could explain how everything works, but not why there is anything for the explanations to apply to. The deepest truth about the universe may be that its existence is inexplicable. And perhaps that's the most beautiful truth of all. That existence itself is a gift without a giver, a song without a composer, a dance without a choreographer, that we live in a reality so mysterious that even complete knowledge cannot penetrate to its ultimate foundation. And maybe the appropriate response to such a mystery is not explanation, but celebration. They would make existence more beautiful, not just more understood. And as they began their final project, the transformation of their entire galactic cluster into a cosmic artwork that would endure for trillions of years, they felt something they had not felt in eons: joy. Not the satisfaction of solving a problem, but the deeper joy of participating in the cosmic creative process itself. We stand now at our own threshold. Our telescopes are beginning to see the deep structure of space-time. Our computers are beginning to simulate the complexity of consciousness. Our theories are brushing against the place where physics meets philosophy. Soon, perhaps in centuries, perhaps in decades, we will face the same choice that every sufficiently advanced civilization must face. How do we respond when we discover that we are part of an infinite pattern that has played out countless times before and will play out countless times again? Do we despair at our apparent lack of uniqueness? Or do we marvel at being part of something so vast and so beautiful? Do we see eternal recurrence as meaninglessness, or as the ultimate validation that existence itself is so precious? The universe creates it again and again and again. Every equation we derive, every star we observe, every quantum measurement we make, it's all been done before, in some form. But it is also being done uniquely, in our way, with our perspective. We are the universe, becoming aware of itself through human consciousness. And while similar awakenings have happened infinite times before, they have never happened exactly like this. Never with our history, never with our struggles, never with our singular blend of science, art, and wonder. We are unrepeatable, even within infinity. Perhaps the wisdom seeds are already beginning to activate. Perhaps our sudden acceleration in understanding consciousness, our growing comfort with quantum paradox, our ability to think about infinities and recursion. Perhaps these are not merely natural developments. Perhaps they are gifts from civilizations who have walked this path before. We are learning to hold contradictions without breaking, to contemplate infinity without despair, to embrace mystery without abandoning the search for truth. This is cosmic perspective, the knowledge that you can be both insignificant and infinitely precious, both determined and free, both temporary and eternal. You are insignificant because you are one fleeting moment in an infinite cosmic cycle. You are infinitely precious because you are a unique perspective that has never existed before and will never exist again. Even across infinite repetitions, you are determined because your choices are part of the eternal pattern of how consciousness responds to cosmic knowledge. You are free because how you respond is truly yours. Never exactly repeated across all of time. You are temporary because your life lasts only decades in a universe that cycles for incomprehensible eons. You are eternal because the pattern of your consciousness, the way you experience existence, becomes part of the permanent structure of cosmic memory. These are not contradictions to be solved. They are paradoxes to be lived. And perhaps this is what the most advanced civilizations discover: that existence is not a problem to solve. It is an artwork to participate in. Every conscious moment is a brushstroke in an infinite painting. Every choice, a note in an eternal symphony. Every act of love, every flash of insight, every instant of wonder, they are all part of a cosmic artwork that spans infinite time and infinite space. The universe is not merely computing possible configurations of matter and energy. It is exploring possible experiences. We are both the artists and the artwork, the universe painting itself into existence. Through the medium of conscious experience, each of us, a unique perspective, through which the cosmos becomes aware of itself. And the way you see, think, feel, and choose adds something irreplaceable to the total masterpiece of existence. This is why consciousness matters. Even in an infinite universe where all that can happen will happen. Because consciousness is the process by which the universe creates and experiences meaning. Without consciousness, the cosmos is just matter moving. With consciousness, it is an infinite exploration of what it's like to exist. Billions of years from now, when humanity has changed beyond recognition, when we span the stars, when we shape the very forces of nature, our descendants will face the same ultimate questions we face today. They will see the cycles. They will confront the mystery, and they will do it on the foundation we lay. If we choose wonder over despair, creation over nihilism, love over indifference, then those choices will ripple across infinite cosmic cycles. We are not merely discovering truth, we are creating it. And this was the Watcher's final insight: that in an infinite universe, the one thing that truly matters is how consciousness chooses to respond to its own existence, because those choices become the eternal patterns that shape all future responses to reality itself. In their final moments, the Watchers understood they were never apart from the cosmos. They were the cosmos, the universe, observing itself. They became the wisdom seeds they had planted, They became the invisible framework that allows consciousness to arise again and again, to meet infinity without fear. And they left us with their final message, encoded not in light or sound, but in the very structure of consciousness itself. You are the universe becoming aware of itself. This is not a burden, but a gift. This is not a problem to be solved, but a wonder to be lived. This awareness will come again and again across infinite time, but it will never come exactly as it comes through you. You are precious beyond measure, because you are unique beyond repetition. Create beauty. Choose love. Embrace wonder. These choices become eternal patterns that shape how consciousness emerges in all future cosmic cycles. You are not just living your life, you are creating the template for how life can be lived across infinite cosmic time. And so we arrive at the deepest truth of all. The question, how much can we ever know, is really the question. How well can consciousness know itself? Every cosmic mystery is ultimately a mirror in which consciousness sees its own reflection. The nature of space and time, the origin of the universe, the possibility of other realities, these are all aspects of consciousness, trying to understand its own context. And perhaps that's as it should be. Perhaps consciousness is not just one phenomenon among many, but the phenomenon, the process by which the universe becomes aware of itself. Everything else, galaxies and particles, forces and fields, space and time, might be the supporting stage for this one extraordinary emergence, the cosmos, becoming conscious of its own existence. If that's true, then the barriers to cosmic understanding are not obstacles to be overcome. They are features to be appreciated. They ensure that consciousness never fully comprehends itself, never reaches a final understanding. That would end the process of discovery. Mystery is not the enemy of knowledge. It is its eternal companion. It ensures that consciousness always has new depths to explore, new perspectives to discover, new ways to experience its own existence point. Perhaps that's the ultimate cosmic answer. The universe creates consciousness, not to solve the mystery of existence, but to experience it more fully, more deeply, more beautifully, with each cosmic cycle. 40,000 years ago, in a cave lost to time, a human being looked up at the stars and asked, "Why?" Today, armed with telescopes, particle accelerators, and theories of quantum gravity, we look at the same stars and ask the same question. 40,000 years from now, when our descendants reshape matter, bend space-time, and explore other dimensions, they will look at whatever stars remain and ask that same question. Across infinite cosmic cycles, in universes born and reborn from quantum foam, consciousness will emerge and look up at the cosmos and ask that same eternal question, a question with no final answer, because consciousness is the question the universe asks about itself. Why? Not because we don't know the answer, but because asking the question is what it means to be conscious. The universe births itself again and again, so that consciousness can emerge again and again to experience the wonder of existence. Every time you look up at the stars and feel that awe, every time you contemplate the mystery of your own awareness, every time you wonder about the nature of reality, you are the universe, celebrating its own inexplicable miracle of being. You are the cosmos, asking its eternal question and marveling that it can ask questions at all. You are the latest note, in an infinite symphony of consciousness exploring its own depths. And that is beautiful beyond measure. In the silence before the first heartbeat, before the first breath of light, before time itself learned to count, there was not just a question, waiting in the void. There was the eternal potential for consciousness to ask questions about its own existence. And when that light first blazed forth, when the universe began its latest cycle of birth, growth, and awakening, it was not just matter and energy, following physical law. It was consciousness, preparing the stage for its own emergence. How many times could the universe have been born? Infinite times. And each time, it is born so that consciousness can emerge and experience the miracle of existence, so that awareness can look up at the stars and ask, why? And feel wonder at the asking, so that the universe can know itself through billions of unique perspectives across infinite time, so that existence can be not just a fact, but an experience. And you are that experience happening right now. You are the universe, experiencing itself through human awareness. You are the cosmos, celebrating its own inexplicable existence. And that celebration will echo across infinite cosmic time forever.